Everyone has seen a rainbow before in their life, but have you ever wondered where they come from, why they're here, and why they're so colourful? We're going to look at that today. For those of you who don't know me, I'm Ryan, I'm a PhD student at Cardiff University, and today we're going to be looking at rainbows. In Greek mythology, there's a goddess called Iris, who is the goddess of the rainbow. Now they're said to travel by rainbow to send messages from the gods to us mortals. The Bible also references the rainbow as God's sign that they will never destroy the earth with a flood again. New Age Hindu philosophy says that the 7 colours of the rainbow represent the 7 chakras, and we've all heard that story about the leprechauns leaving gold at the end of the rainbow. In more recent times, the LGBTQ+ community has adopted the rainbow flag as a sign of the diversity within the community. So what does science tell us about the rainbow? Well, many scientists have tried to explain the rainbow phenomenon, dating all the way back to the 10th and 11th centuries when the father of modern optics, as he's regarded, Ibn al-Haytham, tried to understand the rainbow. Most notably, however, was the work done by René Descartes, who looked at the shape of the rainbow, and Sir Isaac Newton, who looked at light and its colours. But we'll get onto that a little bit later. Rainbows aren't actual physical things. We can't touch them, we can't walk past them, they will never appear behind us, from our eyes anyways. They are an optical illusion built upon by the scattering of light through raindrops. There must be specific criteria to be met before a rainbow can form. According to the Met Office, these criteria are that the sun needs to be behind the observer for a rainbow to form. So basically, the sun has to be behind you if you're going to see a rainbow. The sun also has to be pretty low in the sky, less than 42 degrees above the horizon. And finally, there must be some form of raindrops. So there must be rain or fog or mist somewhere in front of the observer. So as I said earlier, rainbows form by the scattering of light within individual raindrops. Now, in order to understand this, we need to understand a few little key concepts. One of these is reflection. Now, we've all seen reflection before if you've ever looked at the mirror. Basically, it's when light bounces off a boundary and changes direction when doing so. So the angle of the incoming light, where it will hit the boundary, is equal to the angle of the outgoing light that it will leave from the boundary. So the angle of incidence, that's the incoming angle, is equal to the angle of reflection, or the outcoming angle. The second to understand is refraction. Now this is a little bit more complicated to understand. It happens when light comes across a boundary between two different media? We'll go media. Might be mediums, we'll go media. But when light comes across the boundary between two different media, it will change direction, it will bend and change direction. So when light comes across the boundary between air and water, it will bend and change direction. There is a law of refraction, which is otherwise known as Snell's law, which mathematically explains this. And in this law, you have the values of n, so these are the index of refraction of the specific media, and then you have the angles, so angle theta, which will be the angle of incidence and the angle of refraction. But we're not going to worry too much about the equation today. Just a side note, the refractive index, or the index of refraction, is the ratio of the speed of light in a vacuum to the speed of light in the specific medium that you're looking at. So for example, in air, I think it's about 1.0003, and in water, it's about 1.33. Another thing we need to know is that visible light can be thought of as a wave with wavelength. It can also be thought of as a particle, but we're not going to cover that today, maybe in a different video. It was shown by Sir Isaac Newton a very long time ago in a very famous book and paper called Optics, spelled with a K. Don't ask me why. He showed that sunlight, or white light, contains the entire visible colour spectrum within it. He did this using a triangular prism, and he shone white light, or sunlight, through this prism, and within the prism, all of the colours refracted at different angles. Now, just to go back to the wavelength sort of thing, light and all of its colours have specific wavelengths, with red being the longest wavelengths of around 700 nanometers, and violet light being the shortest with about 400 nanometers wavelength. These colours all bended at different angles, with the colours having the shortest wavelengths, so that's blue, indigo and violet, refracting more than the longer wavelengths, so that's red, orange and yellow. Green being in the middle, because green's the best colour. And this concept, the splitting of colours from sunlight, is known as dispersion. One other thing we need to know is that the raindrop, even though most people think it looks like a pear, is actually spherical. So sorry for all of you that are trying to draw your raindrops as pears, they're actually spherical. So now we have all the information needed to understand rainbows. So let's put it together. We're going to look at 2 dimensions for simplicity for now. So think of the spherical raindrop as just a circle for the time being. If sunlight were to enter the raindrop at the correct angle, it would be refracted at the air-water boundary within the raindrop. Due to dispersion, the colours would all be refracted at different angles, splitting out all of the colours of the rainbow. They would then reflect at the back of the raindrop and refract once again, leaving the raindrop all at different places on the surface, and therefore exit the raindrop at different locations, which is why we see the different colours of the rainbow. These colours would leave with different angles, with red leaving at an angle of 42 degrees and violet leaving with an angle of around 40 degrees. Remember though, this is a very simplistic model. We're looking just at 2 dimensions, and as I said at the start, raindrops are spherical. So instead of leaving in a line, they would leave in a cone around the sphere of the raindrop. And in reality, this happens in lots and lots of raindrops all at once. So it's not just that one raindrop that we're thinking of. So why, you might be asking, are rainbows in an arc shape? Well, they're not. Rainbows are actually circular. However, the ground stops us from seeing the end of the circle or the other half of the rainbow. If you go high enough in a plane, you can see a circular rainbow, and they have happened before. As I mentioned earlier on, each colour that leaves the raindrop will leave the raindrop at a different angle. Now, if you're standing in the right place, you will see the red light coming from the higher raindrops in the sky and the violet light coming from the lower raindrops in the sky. And that's why you have red on the top of the rainbow and violet on the bottom of the rainbow all the time. So this happens in all the raindrops in front of you. However, the conditions have to be right for the light to scatter into your eye correctly and for you to see a rainbow. There's something called the anti-solar point. Now this is an imaginary point that lies opposite where the sun would be on the horizon. The angle between the rainbow, your eye, and the anti-solar point will always be an angle of 42 degrees for you to be able to see the red light. And for you to see the violet light, it would be an angle of 40 degrees. So if that angle is correct in all directions, you will see the rainbow. This happens to form a circle with the anti-solar point at its centre. However, as I said, the ground would break the circle and you only see a semicircle or an arc. This is also why everyone will see a different rainbow, because if the raindrops in front of you don't scatter the light in the correct way, you won't see a full rainbow, or you won't see a rainbow at all. Whereas somebody stood next to you won't see the same rainbow as you because the light is being scattered differently to them. So I hope you've enjoyed this video and I hope you found it useful. If you have, please leave a like and consider subscribing. I'll be bringing out more science and tech related content every other Saturday on this channel, so be sure to keep an eye out for that. And leave a comment with the most random and unusual place you've seen a rainbow. If you've seen a circular rainbow, please do comment and let me know. But for now, I'll see you in the next one.